The typical question would be, what stuck out to you from the lesson this week? What?
Ultraviolet light.
It was pretty much all. Yeah, this was all kind of familiar to me.
Oh yeah.
Yeah,
Okay.
it was kind of a recap for me too. But I really liked
That
the part
was
where
the most.
um
That was interesting to me. I
What was
like
it
the
that?
ultraviolet light too.
Okay. What about ultraviolet light?
I forgot what I was going to say. I didn't know everything about ultraviolet light yet. Like I didn't know that UV rays have wavelengths between around 10 and 400 nanometers. So I didn't
Okay.
know that. But that's really the only other piece of information it gave us in this lesson about UV rays. I don't know. They've just always interested me.
Okay. What was interesting to you about ultraviolet light, Jonathan?
It was the it's the same. It was the same.
Okay.
I don't really have anything to say.
Same thing that Daniel was talking about. I thought that was interesting.
Okay. What about other people? What did you find interesting? And how was it new, or was it? I mean, was it fairly new? Was it fairly stuff you already knew?
I found the part interesting about where if they did a reading of the color that comes from a star and like the wavelength of it, they could like tell exactly what its chemical composition was and like how old it was and all that stuff.
That is pretty
And
amazing. How much
then
they can
part,
figure out just from the spectrum, the spectrum of light, like all
yeah,
that stuff they can figure out from that is just wow.
like how certain stuff burns a certain color and like the little spectrum, the black lines in the spectrum or whatever would tell them like it was the something about the absorption, about how certain chemical would absorb the same kind of chemical, and that would be the little black line on the spectrum.
Yeah.
And so they would be able to tell exactly what that was. I found that really interesting, and that was all new to me. I didn't know none of that stuff.
That's fascinating. Hello, Noah. So the question I'm asking is my usual starter question, which is, what did you find interesting? What stood out to you? Um, was it mostly new, mostly review? What was interesting? Even if it was review, what stood out to you, etc. And about half the group has shared so far. So Noah, Anna, Azuma, what stood out to you from this lesson?
Um, well, I think many things are very important. For me, I refreshed my mind. I knew some things, but for me, maybe the interesting part is the different length of waves. So I think this one is very important for me. The ultraviolet and the ray, the X-ray, and those waves or those electromagnetic spectrum are different. Have different waves lengths. So I think those are very important.
Okay.
Most of it was review to me. It just was more that I thought it was interesting how, since not all wavelengths can go through the atmosphere, that's why there has to be things um, in space, not from Earth.
Yep. So we are eagerly awaiting the James Webb Space Telescope, which I believe last I looked was set to launch October 2018, I think. which we'll be able to do more in the give us more information in the infrared, and I don't remember what other spectra. But I know some of the range in the infrared that can't be, infrared can't go through Earth atmosphere, and we're going to be able to get a lot more detail from that James Webb Space Telescope that's due to launch, which Daniel's dad actually worked on it a number of years ago, which is very cool.
Like around 2007, 2008, around that time, he actually worked at NASA.
I always think that's very cool. Yeah.
Yeah, I have sound now.
Go. Whenever my husband and I are reading about, we follow a lot of space news, and okay, my husband follows and shares with me, so I vicariously follow. We talk about when we're together. He'll pull up some article on his phone that he's just read something about, and share with me the latest news of this and that. We were just looking up something the other day about different wavelengths and different which of the space telescopes can process different wavelengths and all that. We were just looking into, and I always think about Daniel's dad whenever we were actually talking about. I mean, Daniel's dad is a cryophysicist, which means dealing with really, really cold temperatures, and we were talking about one of the particular instruments that's on the James Webb Space Telescope that has to be kept at like 5 degrees Kelvin or 15 degrees Kelvin or something like that. It's been ready since 2012, and until it goes into, it has to be kept at that temperature. So it's just in cryo storage. So I thought that was fascinating. Anyone else? Nothing in general? Okay.
Okay, sorry.
Go ahead. Yes, something.
Okay, for me, it's interesting that the astronomers can have special telescopes to see the non-visible electromagnetic spectrum, and then they can say, oh, that star is new and so on,
Yeah, it's amazing with those different wavelengths, what all the different kinds of things that they can tell by all of that, the information that we get from different wavelengths. It's we have radio telescopes, we have telescopes that can measure the infrared, we have telescopes that have special X-ray or ultraviolet, or those that deal with gamma rays. I mean, just and each set of instruments can only measure one range, and so depending on what the purpose is, so we're used to seeing images coming back from Hubble, and Hubble is visible light spectrum into the ultraviolet light spectrum, if I remember correctly, and so we're used to seeing more visible light spectrum. When like the James Webb Space Telescope isn't focused on visible light; it's focused on infrared. And so, we won't see the same, but it'll give us lots of very valuable information, just not in the visible spectrum like we're used to seeing. So, okay. Going to a different part of the lesson now, just a second. Before we go to the lesson itself, what kinds of things did you guys learn from the exploration? What insights did you learn from the exploration? Nothing? Nothing at all?
It basically just the wavelengths that was it was more about their frequency and wavelengths.
Yeah.
Okay, can somebody else repeat whatever Noah said, because it was chopping in and out as he was trying to say it. I didn't hear most of what he said. Or else, Noah, you can say it again. I only got a couple bits and pieces of what you said.
It covered basically the wavelengths. It just went into more specific detail about the exact frequency and the exact wavelength, like the
Okay.
math.
Okay. Alrighty. I know this and have known this for a long time, but it still is fascinating to me that the whole electromagnetic spectrum, from radio waves to gamma waves, radio waves, microwaves, the infrared heat radiation, that little tiny sliver of that's the visible light spectrum that we see, to ultraviolet, to X-ray, to gamma ray. I mean, that all of that is just a matter of what kind of wave we've got. I mean, what kind of wavelength we're dealing with. That's all on the same continuum. I mean, it's still, like I said, I know this and have known this for a long time, but that radio waves and microwaves and X-rays and our visible light are all just different variations of the same spectrum, to me, is still hard to wrap my mind around. I think of them as something very different, but they aren't. Which of the different parts of the magnetic spectrum, gamma rays, X-rays, ultraviolet, infrared, microwave, or radio wave, do you each find to be the most interesting, and why? Why do you find that particular set of the spectrum to be the most interesting? I know two of you mentioned something about UV. I'm just curious, what is it about UV that made me think about that? But I'm just curious for the others of you, both for the two of you who mentioned UV, but then, so why is the UV the most interesting to you? And then others of you, which of those do you find the most interesting, and what is it about it that makes it that part particularly interesting to you?
I think it says that the UV, X-ray, and gamma rays are all do this, but probably mostly gamma rays because they're highest frequency. But I think it's most interesting that they just damage living cells.
You think it's most interesting because what?
They damage living cells.
Yes, they do.
One thing that interests me about UV rays that actually wasn't said in this lesson, I don't know why it would be, it's that UV rays can actually make certain things glow.
Mm-hmm.
That has always really interested me because a few years ago at like this book fair at my school or something, I got this pen and you could write with it and then shine the light that was on the back of the pen on your writing and it would glow. It was like invisible ink.
Cool. Cool. Others, which of the spectrum do you find the most interesting, and why?
Not really retaining to any specific one, but I found it really interesting that each wave, no matter what it is, has its own frequency, like its own specific thing that you dial into, no matter what kind of wave it is.
Mm-hmm. That isn't definitely interesting. Why are astronauts particularly exposed to high levels of X-rays and gamma rays?
Because they're outside of the atmosphere, and the atmosphere usually cuts down the level of gamma rays and all that stuff. And so when they're out in space, they're exposed to the high level of it, just floating around in space.
Yep, I mean, right within the space station. I mean, you don't even have to be out on a spacewalk to be being exposed to more. So the atmosphere, and then also our electromagnetic, our magnetic magnetosphere, also provides a substantial amount of protection. At certain stages of our planet's formation, there actually wasn't as strong of a magnetosphere, and only certain portions of the Earth were more well shielded than others. Just by as the magnetosphere was forming, it was not as complete of a magnetosphere, and so stronger near. It's still weaker near the poles, but it was much weaker near the poles in the earlier formation of the Earth. Just again, also interesting that it's not. You think, oh, this is just how it always been, and things changed over time, allowing different things to different conditions, for life to flourish. Some planets have much more of a magnetosphere than others, and that magnetosphere, as well as our atmosphere, provides a substantial amount of protection for us. I mean, the Chandra X-ray Observatory is a space telescope that specifically focuses on X-rays, and they can pick up different stuff than like a visible light spectrum. Anybody else have other portions of the electromagnetic spectrum that are more interesting than to you? Just to stand out to you guys? Any particular one for anybody? I think it's fascinating that whereas we can be very much damaged by particularly the gamma ray, X-ray end of the range, if we get too much exposure to it, we also can use those for good. I mean, you can use a limited amount of X-ray exposure. You go to the dentist and get a tooth X-ray of your mouth. You find out, oh, I've got a cavity, or you verify that no, your bone's not broken. You didn't fracture your wrist. It's just a sprain, or whatever. That a small amount of that can actually be very helpful to us. And so this something that can be both damaging in excessive exposure can actually be very, very useful to us with small amounts. People use UV rays to help sterilize, actually UV and X-ray, like medical equipment and stuff like that. You can use ultraviolet rays to help sterilize, which means it's slightly harmful because it's killing off stuff, but what you're killing off is bacteria that you don't want there.
Those waves, they don't curve, so you just can use the ultraviolet waves to sterilize this how can I say, plane surface, and the X-ray also cannot curve. And I don't know why this wave cross some materials, but don't cross other materials.
Mm-hmm. Yeah, so certain wavelengths are able to pass through some materials and not others.
Yes.
Sure. Mm-hmm.
I don't know if it has something to do with the frequency.
I'm sure it has something to do with the frequency. I would think it has something to do with the frequency. Yeah. So gamma rays can definitely harm cells. We specifically also use gamma rays because they can harm cells. In focused manner, we use them to target cancer tumors. So like that's one of the things they use for cancer treatment is they target gamma rays at cancer cells. They just have to make sure they don't target it at others. They want to target it at the cancer cells and not the rest of the cells. But they actually, like, yes, gamma rays can kill living cells, but we use it to kill cancer cells. Sometimes it's called radiotherapy. Healthy cells can repair themselves fairly well when they're damaged by those gamma rays, but the cancer cells can't. So again, another way we're able to use, and gamma rays and actually ultraviolet both are used to sterilize medical equipment. Another usage for gamma rays would be radioactive tracers. So they will put like a contrast to be able to, like maybe if you're doing an MRI, that they need to be able to see the difference if this substance is going through your body, and be able to see where like the blood flow. And so if they use like a contrast, a dye contrast that then has this bits of gamma rays, or that they can then use that to then image things, specific things at places in your body where they need to get a much more close image of the difference between when the radiation is there and when it's not. When I have a small growth on my pituitary gland, and so every couple of years I have to go in for an MRI, and they always take a set of MRI pictures without the contrast, and then they put another set with the contrast to see the comparison between the two. That's one of the ways that they use to help keep an eye on it, keep track of it, and monitor. Is it under control? Is it doing what it's supposed to? So, sorry, I'm skimming for the next thing I wanted. Did you guys figure out what images they were talking about? They're showing different images of like the
It
No.
was the ones on the Engage page, where there was the videos. It was before you hit the play button. There was the picture of what it looked like on the video.
Okay, I'm skimming through the Explore page. That's why I'm like, and they did mention that it was on the Engage page. Thank you. I was like, where am I looking? I'm missing
But
this.
once you hit the play button, it wouldn't show it again. So it was only right at the first moment there.
Sure. So, seeing the fact that you can see different stuff depending on which kind of telescope you were looking at stuff with. We get different information depending on. We get more of like what we think of as a full picture. We actually get a full picture, or more complete picture, by having the information from the different spectra. Great. Okay, thank you. I was just skimming. I'm like, this was not computing in my brain. If they're mentioning some image, I'm like, I can't find the image they're talking about. microwaves that like you use to heat your food, the fact that they're like in the same spectrum as the or all this other stuff, you go from infrared, which kind of makes sense. Infrared is dealing with the heat energy, so I guess it makes sense that between there, you go from heat energy to then the next thing, these microwaves that are actually able to heat food. And then your next category is radio waves. So you listen to something through radio waves. Your cell phone technology and television signals all use radio and microwave, which I guess makes sense why if you run the microwave you might mess up your signal for something if you've got something that's too close in frequency.
Some cell phones will mess up like a FM radio signal because they'll mess each other up. Like when my mom sits at the table next to the radio, it makes it go all fuzzy.
Yep. So they're close enough. They've got similar overlapping wavelengths enough that they can mess with each other. Sure. Yes. So some of these wavelengths can cause cancer. Too much exposure to say ultraviolet light, the UV rays from the sun. If you're laying out sunbathing too much, you're getting too much of a tan, you're getting too much exposure. When you're getting a tan, your body's actually trying to make protective. It's protecting itself from being too exposed to too much of the ultraviolet rays. That's what it's trying to do. That's the purpose. But people who get too much sun exposure, and some people are more prone towards getting skin cancers. It's particularly people with much more lighter complexions, which tend to be people from maybe Northern Europe, where you haven't the generations haven't developed an environment that's as close to the equator to need quite as much protection on a routine basis. So darker skinned people tend to have developed over time in parts of the world near the equator where their skin naturally needs to develop just more of a natural protection, whereas those who live in climates that are further away from the equator don't need quite as much of that, and so we tend to have fairer skin, lighter skin tone, and we tend to be more at risk then for if we are exposed to more of the sun, you're working out here.
And supremacists call us a better race. Can you believe that? We're more susceptible to sunlight. We should be envious of the guys who can protect themselves from sunlight.
Sure. Yep. And so some people try to say that, hey, the Nazis try to say that, that because we have the fair skin, we're better. Yeah. Well, there's one thing we definitely weren't better at.
This probably isn't true, but maybe that's the reason. That's the reason why those guys hate those people in the first place, because they have better skin protection. Probably not, but
Right. Interesting to think about. But yeah, where your ancestors have developed depends. Do you need to develop those kinds of safe? If you were somebody who has very fair skin and you live near the tropics, yeah, your body develops that pigment, the melatonin. You're right, Anna, to help darken your skin to protect it more from the harmful UV rays.
What you meant to say was melanin. Melatonin helps you sleep.
You're right. I get those two confused. Melanin, you're right. Melatonin is the substance that helps you sleep. Melanin is the substance that is in your skin. You're right. That's
well, now
I get those two confused too.
Now I can walk up to someone from the KKK and say, "I think you're jealous."
I'm guessing that would probably be not wise.
I wouldn't actually do that, but you know what I mean.
Yes, I do. So if you had a lighter skin color, you wouldn't be as likely to you and your descendants wouldn't be as likely to survive if you were in a more that's why people with darker skin were the ones who would be more likely to survive because they were protected from the harmful UV rays more. So makes sense that those who live in over thousands of years, your ancestors live primarily near the equator tend to have darker skin because they're the ones who are likely to survive. Totally. I find it interesting that our human eyes can only detect such a very small portion of the electromagnetic spectrum. Our eyesight's only designed for a very, very small portion of the electromagnetic spectrum. But we have been able to develop technology that's allowed us to sense, both sense and detect the other portions of the electromagnetic spectrum, but then also harness and use other parts. I think we were using things like radio waves before we even fully understood that they were part of the same spectrum. So the fact we understand they all go together. How many of you have played with prisms? Hopefully most of you have gotten a chance to play with a prism at some point.
I think I almost blinded myself last time I tried.
Yeah, I've used one.
Okay. I'm hoping most of you had a chance to explore and play with prisms and explore seeing the light and the rainbow coming through.
It's like messing with a camera and not remembering which side is forward.
I guess that's one way of thinking about it. Did you know that I don't know if they mentioned it in this lesson or if it was someplace else. I know it from somewhere else that we actually discovered helium first in the sun's with a spectrograph. We actually discovered helium first on the sun, and then we realized we had it here on Earth as well. That was how we discovered the element. Very common, but we didn't know about it here on Earth until we had actually seen it first in the sun spectrograph lines. I guess I should have added more to this lesson. It wasn't a long enough lesson for you. Wasn't enough information. Should have added stuff to it. Okay. So going on to the page 2, then we're talking about different types of telescopes and how they work. So that allows us to capture the information. If we're I'm trying to think how to ask the question. So optical telescopes are just magnifying the amount of visible light we're seeing. So there are other specialized types of telescopes, but the type we think about most are optical telescopes.
And there are infrared telescopes, like telescopes that can detect gamma.
Mm-hmm.
And there's one that can just magnify like crazy.
Sure. And the larger the telescope. Go ahead.
And a few telescopes combine almost everything.
So some combine different types of spectrum. Most of the telescopes have specializations of which type they focus on. There's actually some radio telescopes that are actually combined. They're actually very widely spread apart because of how the wavelength they're dealing with. That they, in order to capture those frequencies well, they actually have different receptors that are spread out over quite a big distance in order to take all of that. So the larger the lens, the better we can magnify images, but if they're too large, their own weight causes them to sag and then distort the image. Did you guys know that when we sent up the Hubble Space Telescope, there was a defect in the mirror? So we spent huge amounts of money sending up this telescope, and there was a defect in the mirror causing it to not be able to take good images. So we more or less had to go up and put a contact lens on, an analogy, but we pretty much had to put a contact lens on Hubble to correct the distortion in its lens in order for it to see well.
Because it was too expensive to go up there and take the lens out and put a new one in.
Yeah, it wasn't even feasible, practical to just replace the lens. It wasn't something we could really do. So what we could do was make a corrective lens to go over it. So the analogy of a contact lens is helpful to understand what they did basically to fix that. But huge, expensive telescope, and thankfully it was close enough to Earth that they were able to actually go service it. And they've actually gone up and done a number of servicing missions. As the space shuttle program was coming to an end, they actually, the last servicing mission they actually, I believe, brought it down closer to, or near the end, maybe not the last one, closer to the end, they lowered the orbit of the Hubble Space Telescope some, so it could be easier to get to without having to go to super high up where it was, because they had wanted, after the Columbia disaster, when the Columbia Space Shuttle, if there had been something like Columbia where they had damaged the heat shields, they wanted to be able to have enough fuel left to be able to get back to the space station if necessary, to get the crew off in the future. But as they were coming to the end of when the space shuttles would be running, we weren't going to have anything to be able to go up and service them. Originally, the Hubble Space Telescope was set that they would eventually, because it's large enough that they need to, when it's not going to be continuing servicing anymore, they need to be able to have a plan to deorbit it in a way that it's going to deorbit over the ocean in case large pieces would still be left and not burn up in the atmosphere. You wouldn't want large pieces of Hubble destroying somebody's house or something. So when in their last mission, they actually put some programming into it to be able to do it with just a robotic mission to do that. Basically, we're the deorbiting process with a robot instead of with humans triggering it when it's time. There have been different, depending. They also replaced some gyroscopes that help keep it able to point where it needs to point and work. That they replaced some gyroscopes that were failing, and they think they figured out why they were failing and replaced them. So depending on how long different instruments and different things keep working, estimates have been made of through 2020 on up to maybe even through to the 2030s and 2040s, possibly, how long the Hubble Space Telescope could keep going. And it depends on different parts, how long things keep working.
And who knows, they might probably bring it down and send up another one that's probably 3 times as good.
I don't know that there are any other visible ones in the current docket of what's being planned. I mean, the James Webb Space Telescope's been being worked on for years and years and years. Right now, we've been seeing pictures of. We've been watching. Dan and I've been paying attention. We've been seeing pictures of the processes being put together. It's It's huge. It's massive. But it's been quite a number of years ago that started. So it's a long-term process to get any of these going, and they're very, very expensive. It makes sense. You've got an instrument that needs to be kept in cryo storage at 5 to 15 degrees Kelvin or something like that for years on end. That's not a cheap process. There's other things. There's huge portions of these processes that they're doing that have to be done in a total sterile environments. They have to have special huge rooms to assemble these things that have to be kept in a completely sterile kind of environment where they have, you go in or out, you have to be in complete protective gear so that they don't have any dust or dirt or other stuff getting on these components that they're putting together. So it's a very expensive process. Who knows when we'll get around to deciding to put up another visible light telescope. I don't believe there's one in the plans currently, from what I understand. That they don't have, that's not in the current plan. But Hubble's brought us back some fascinating stuff, some amazing images. Uh, One sec. I mean, it does all sorts of different things, and it's, you've got to have something really important in order to get time on Hubble. All sorts of people would like for their research. Oh, I'd love if Hubble could get an image of this, but generally it's going to be something that's fairly new research, very, very something that's going to further our understanding in a new field, not just, hey, I'd love to get an image of that, but like they used sometime in the time leading up to when the New Horizons probe was getting to Pluto. They used some specific time on it to help scout in the direction where New Horizons was going to be going. Were there other interesting solar system bodies that they could send it past? Like if they could use a little bit of fuel to change its trajectory slightly, to plan for it to go check out something else. Check out something else while it's out there, not just to Pluto. And so I know that they specifically used some time on Hubble to explore that. Dan and I were actually just looking at images. The Hubble Deep Field is looking very, very far back in time and seeing very, very distant galaxies. I'm trying to get an image to pull up, and I'm having trouble at the moment. Ultra Deep Field is more recent. But so images we have of just distant galaxies, you're seeing, and this is just one little point, one little direction in the sky that Hubble's pointing its telescope and gathering this information. If you imagine what it could be if you could look in different directions. I'll be very curious to find out when they send James Webb Space Telescope up, if they choose to focus on, like if they go focus in the same area where Hubble had been to get, hey, what information do we add now that we can add this infrared? Because infrared lets us see much further, and add that information to what we already have, or if we'll choose to look at a different segment of the sky. Don't know. At the moment, I'm not getting the search engine to do anything, so I can't look that up. I'm going to try a different way. So there are two major types of telescopes for optical. What are the two major different types of optical telescopes?
I think refracting is one of them.
Okay. Yep, refraction is one.
Reflection.
Yep, refraction and reflection. So what's the difference in how they work?
The first one allows you to see the visible light, and the second has curved mirrors and magnify the image.
So both refracting and reflecting telescopes are dealing with visible light. The reflecting is doing mirrors, like you said, so it's using mirrors to reflect it. Whereas, what does the refracting telescope use instead?
It uses different light density.
So it uses lenses. So it's using lenses that are going to like curve glass. That fun.
Like it operates a lot like the lens on a camera. You know what I mean?
Yep.
It does do its job. Like it's not meant to get a really close up picture, but it makes it close enough so you can see what it is. Like the one that uses the set of mirrors results in a much cleaner image and a lot more magnified, and it was mainly because Sir Isaac Newton perfected it.
So yeah, we've had improvement in both of those over the years, and you get again they have different, they work differently. You can join multiple mirrors together to make it act like you can get a much larger telescope with a reflecting telescope because you can join multiple mirrors together to work together, whereas a lens needs to be ground as one single lens. Didn't mention it here, but Galileo was the first to practically turn the telescope to the sky, would be a refracting telescope, and to refine it to use for observing the sky. They had been in existence before. Sometimes it's often miscredited to him as having been the one to create the telescope, which is not true. But he was the first to practically use it for sky observations. Okay, so I finally got a picture of the Hubble's deep field image to come up. I'll screen share here for you in a sec. I hope. Alright, one sec. Again, Dan and I were just talking about this the other day, not because of class or anything, we were preparing for class, just because we were discussing this. Come on. Alright. Am I successfully screen sharing?
Yes.
Yay!
Yeah.
So this is the Hubble Ultra Deep Field image. Basically, they found a spot in the sky that basically pretty much black to the visible to normal optical to the normal eye from here on Earth, and a normal telescope it looks pretty much dark. Like you just look out and any of our more smaller normal telescopes you wouldn't see anything. And they focused the Hubble. It was done over the course of about a month each of 2 different times, and it was about 11 days total worth of observations done in about 20-minute chunks. But this is pretty much everything you see here, with the exception of the ones that have the lens flare, like look like there's like light in a cross kind of pattern, that kind of thing. Those would be smaller. Those would be stars that would be closer in, that rather than a galaxy. But pretty much anything that doesn't have that lens flare, you're seeing every one of these spots are galaxies, far off distant galaxies, and it's just fascinating to see. This is just one little small chunk of the sky, and some of these galaxies just show up as pinpricks of light. So, but beautiful, fascinating. Anyhow, just wanted to share that. How many of you have gotten to look through a telescope? Have you had the opportunity to observe through a telescope before?
Yeah.
Yes.
What did you get to see?
Like a couple of years back, I went to Brainerd, Minnesota. We stayed in a place that had a Stargate, a really powerful stargazer. I turned it toward Venus.
Oh, cool. What did you notice? What do you remember from what you saw on Venus?
I mean, mostly all I could see was it was a very bright area. It was a very bright spot on the sky, but I couldn't really make out too much detail because it was actually kind of bright despite it being at night.
Okay. Others of you have had a chance to use a telescope. What were you able to see?
I've gotten to use one that was it wasn't very big though. We went to this thing that we call Star Party around here, where everybody goes out at like middle of the night, and they use this big telescope that astronomer brings. And we got to look at a couple different galaxies. I don't remember which ones they were, but they were really cool.
Cool. I got a chance to use one someplace that was at like a science museum type place, and they had a observatory, and we got a chance to see Jupiter and 2 of Jupiter's moons. I remember. I think I also got a chance to see the moon with the telescope, a much smaller telescope, sometime previously. So those are the 2 things I remember getting to see. I've only gotten to use a telescope like twice, so. Anybody else get a chance to use a telescope?
Yeah, but
Nope.
I think we just looked at the moon and saw like the craters and what's on
Okay.
it.
So it wasn't an incredibly powerful one. You didn't get a chance to see a lot. Okay. But still, looking at the moon and seeing it seeing it closer is still pretty cool. Okay, just curious if anybody else had the opportunity to use a telescope and what your experience had been.
I used it once, and one thing that I thought interesting is that the starlight comes and goes, and the planets don't, you know.
Yep. So the planets are going to be more steady, whereas the starlight is more blinking. Sure. Mm-hmm. All right. So we do not have class next week because we have spring break. The following week we will be back together and talking about. Now, when I say that, you are still. I mean, obviously, you can choose when in the next 2 weeks you do your assignment. It's posted for you. So if you have things. Hey Josh, can you mute your mic, please? I'm getting a lot of background noise. Thanks. Obviously, if you have an opportunity to get together with people who are off this week and you want to spend the time this week with them and then do the assignments next week, I don't care when you do the assignment. We are discussing on April 4th, so we will have that Monday. I mean, we don't have classes on next week. So this week, if you are in my other classes, we do still have class. But like science-wise, you won't see me for 2 weeks. When during this time, the next 2 weeks, you decide to do it, I don't care that much. Just please do the assignment and have it done coming back for class so that we can have the conversation. And the conversation will be April 4th. I have it set. Next week is the week we aren't having group classes. So but when in there, otherwise, I don't care. It's particularly like those.
This coming week, I was going to do the geologic time one because I missed that one from being sick. I just crossed it off and decided to come back to it later. So I'm going to do that one first, and then I'll do our upcoming one.
That's fine. So the next topic is going to be measuring distances in space and what we do with that and how that works. I purposely did give you that one, which is slightly shorter than some because it's coming up to spring break. So I gave you one that's a little bit lighter coming up to that. But interesting stuff there as well. So that is our next topic. The next time we will discuss it is April 4th. Again, for the 4 of you who are just doing Monday classes with me, between now and next week, when you're in between now and 2 weeks from now, when you do it is up to you. those of you in ILS, obviously you're still in group classes with me this week. We still have class sessions, because this is still school, and next week is our break scheduled. So, if there are no further questions, I will see you in 2 weeks for this class.
I have a question, but I'll talk to you after.
Okay. ILS students, I had a mistake on the date. I changed it, but the dates were off by a day for this week. I fixed that in the assignments, but they were just off by a day. I was guessing you probably figured that out since there were the 3 assignments for the day this week. You probably figured out which ones they were, but just clarifying that those dates have been fixed now. All right. If there are no further questions, you are certainly welcome to be dismissed. Noah, if you want me to stay on for a minute, I can answer whatever your question is. Everyone else, you are welcome to go unless you have some question for me.
Alright, I think I'm gonna go. I got other things to be doing.
No
So
problem.
see you next spring break then.
Yep.
See ya.
Continue. So Noah, what can I answer for you?
Oh yeah. What I wasn't able to get